Today's lesson will be on the tangent ratio. Last couple lessons have been mostly on Khan Academy. It doesn't match up perfectly to our lesson package, but it's going to start matching up from here on in. So learning goal for today, after today's lesson, I can use the tangent ratio to solve for missing side lengths and angles in right angle triangles. Very important, they are right angle triangles. This will only work in right angle triangles. So a couple things we have to look at for today's learning goal is this funny word tangent. We've seen it pop up every now and again. A line that is tangent to a circle or tangent to a curve. It's for now it's a magical button on our calculator. We're going to start to use it more and more, and you'll begin to see where this ratio comes from. The second thing we have to make note of is this angles in right angle triangles. Everything we do for the next couple lessons will be with right angle triangles. You'll see when we get to a point where we can stop using right angle triangles, but for the next couple lessons it's all going to be right angle triangles. So let's take a look at the first problem here. You can read that if you'd like. First question says, calculate length E. How does this relate to tan 36.9 degrees? So before I even look at that tan of 36.9 degrees, I'm just going to take a look at my triangle and show that they are similar triangles. So if I look at triangle ABC, how do we know that triangle ABC is similar to triangle DEF? Well, that little square means 90 degrees, so both those triangles have one angle at 36.9 degrees, one angle at 90 degrees, so we can say by angle, angle, and of course that third angle will be the same. We don't have to worry about that third angle. So they are indeed similar triangles. So then we take a look at the side lengths, and more importantly, the ratio of the side lengths. So I know whatever I did to 3 to get all the way up to 12 is the same thing I'm going to have to do to 4 to get all the way up to E. So that'd be my scale factor I was talking about before, or we can take a look at our ratios to actually solve that. So I'm saying the ratio of BC to EF needs to be of the same ratio of AC to DF. And we can start to fill in some values that we know. BC being 3, EF being 12, needs to be equal to AC being 4, and DF being E, our unknown. Once again, we have this unknown in the denominator, so I'm going to move that into the numerator so I can solve that. So I've got E over 4 is equaling to 12 over 3. Flipped both my fractions upside down. Multiply both sides of the equation by 4, and you've got 12 times 4 divided by 3, where we've got E equaling to 48 div 3 is equaling to 16. So we can see clearly our scale factor was 4, so 3, or side length BC times 4 is 12, and AC times 4 is 16, gives us side length of DE. So once we've solved for, calculated for length E, we need to take a look at how this relates to tan of 36.9. So this tan is a weird button on your calculator you've never used before, so I'm going to show you how to type it into your calculator. So once again, just like before, you need to be using your own scientific calculator because everyone's calculator is slightly different. So here I've got Desmos' scientific calculator pulled up so I can show you. On this calculator I type in tan of 36.9, and it automatically spits out the answer at the rate of 0.75 and a bunch of decimals. I'm going to round this decimal to 0.75 for now. It's a bad habit to get into, but just for our first example, we're going to take a look at that. Some of your calculators may require you to type in 36.9 and then type in tan. Just make sure you can get that answer on your calculator. If you consistently not get that answer, it may be, here you can see I can change my calculator between DEG, stands for degrees, and RAD, stands for radian. We're working in degree measurement, so you need your calculator somewhere to say DEG. You'll get used to your own calculator. If you can't figure it out, Google it. I'm sure you can find an answer there. So back to our question there. They're saying, how does this relate to tan 36.9? I'm going to use a pencil instead of a highlighter. So we just found out that tan of 36.9 degrees is equal to 0.75. And that's just something magical our calculator did for now. We're going to take a look at exactly why that is the case. I'm going to rewrite 0.75 as a fraction, and you're going to see why in 2 seconds, is equal to 3 over 4. 0.75 is 3 over 4. So if I go back to my original triangle and take a look at my two side lengths, so if I'm taking a look at these two side lengths, 3 and 4. So they're saying the tan of this angle is equal to 3 divided by 4, or 0.75. So we're going to take a look in the next triangle and see if that's true. So tan of 36.9, so 36.9 hasn't changed, but is this what we call the opposite angle, 12 divided by 16, still equal to 0.75. So it's 12 divided by 16. That must be equal to, 4 goes into both of those, 3 of 4 is equal to 0.75. So this tan button, it measures the ratio of the opposite side. That opposite side is opposite the angle we're looking at, divided by the base, or what we also call the adjacent side. So the tan ratio measures that ratio of the opposite the angle we're looking at, divided by the adjacent, or the base of that triangle we're looking at. If that didn't make a whole lot of sense, don't worry, we're going to do a bunch more examples. You're going to see where that is coming from. So next question says, use your calculator to find tan, or tangent, of 31 degrees. Draw two right triangles with one angle of 31 degrees. So I'm going to draw my triangle. It's going to look somewhat like 31 degrees. I've got snap to straight, so it may look a little straighter than yours, but that should be a 90-degree angle there. Remembering we have to use 90-degree angles in order for tan to work. And I'm going to label this one 31 degrees. Then they're asking, hey, what are these two side lengths, or two different possibilities for those side lengths, if tan of 31 degrees? So I'm going to go back to my calculator and figure out what is tan of 31 degrees. Backspace there. Tan of 31 degrees, my calculator is in degrees, is 0.6. I see there is a bunch of extra decimals there. I'm going to ignore those extra decimals for now. So tan of 31 degrees is equal to 0.6, roughly there. So if I want to draw the ratio of my opposite to my adjacent side, I know that technically 0.6 is divided by 1. Every number is divided by 1. We would just never actually write it out like that. So one possibility for my triangle would be to have my opposite side, spelled correctly, of course, opposite the angle I'm looking at to be 0.6, and what we call my adjacent side or my base to be 1. So one possible triangle, I'm going to redraw it here. Example 1, right about there. 90 degrees. If this is 0.6, this is 1. That means this is 31 degrees there, and that would be 90 degrees. I'm not too sure what my hypotenuse is yet, or that longest side is yet, but that's okay. We're going to leave it alone. Notice this question does say draw 2 right angles, one with an angle of 31 degrees. So I'm going to draw a slightly bigger triangle now, and I'm just going to scale up my 2 adjacent and opposite measurements to be something slightly larger, that when I divide the 2 of them, I still get 0.6. So if this is 31 degrees, I know tan of 31 needs to equal 0.6. So when I divide my opposite, so this is my opposite side, I'm going to call it OPP for short. I divide my opposite by my base, or my adjacent, ADJ for short. I need to get the answer of 0.6. So there's an infinite number of possibilities here. I'm going to multiply both those numbers by 10. So I'm going to get my opposite being 6 and my adjacent being 10. So then if I take a look at tan of 31, it is 6 divided by 10, because that's my opposite divided by my adjacent, that pattern we found before. And I realized that the tan ratio of 31 degrees, it's still 0.6, because 6 divided by 10 is 0.6. It's just a scaled up version. So it's a similar triangle to the one before, just a scaled up version. Questions on that? Feel free to email your teacher or drop by office hours. So in general, what we say is tan ratio uses the opposite and the adjacent side. So can you highlight this, or can you put a big star beside it? And we're going to use this over and over again. And another way to think of this is called TOA. Tan, opposite, and adjacent. So that means tan of some angle, happen to be 31 or 36.9 degrees, but some angle, I'm just going to refer to it as theta. That funny looking O with a line through it is called theta. It's an unknown angle. Is always going to equal, TOA is op over adjacent. So we say that tan, TOA, tan is equal to op over adjacent. So that's where the TOA comes from in TOA. And you may be thinking very well and dandy, but how is this going to be of use to us? Let's take a look at a problem where we don't have a set of similar triangles. So notice we only have one triangle in this problem, and we have a missing side length. It is very important that that missing side length is opposite the angle. So this is the angle we're looking at, 26. So the angle opposite 26, or sorry, the side length opposite 26 is x, and the base of the triangle, or the adjacent, is 15. So I'm going to write that out over here. My op is equal to x, unknown. My adjacent is equal to 15, and my theta, or my unknown, there's a bad theta there, my theta is equal to 26 degrees. Notice how your opposite and your adjacent can change depending on what angle you're looking at. So if I happen to be looking at this angle down here in the bottom, then all of a sudden my opposite would be 15 and my adjacent would be x. So opposite and adjacent depend on what you're looking at, what angle you're looking at. So if we take a look at this angle right here, I know that tan of any angle, theta, is equal to op over ADJ, adjacent. So we can fill out some values we have. I know theta. Theta is equal to 26 degrees. I don't know my op, so I'm going to leave it as x. I do know my adjacent. My adjacent is 15. So here I've got an equation with one unknown, x. X is being divided by 15, so I'm of course going to multiply both sides by 15, multiply this by 15, multiply this by 15. 15 divided by 15 is 1, and I'm going to be left with x isolated on my right hand side, and on this side I'm going to have 15 times tan of 26 degrees. I could put a little bracket around that, symboling that tan, or 26 is attached to tan. Usually when we don't write a symbol in between two operations or two constants or two variables, it means multiply. Notice that tan is not being multiplied by 26 degrees. We're saying it is the tan ratio of 26 degrees, so there's no multiplication there. The only multiplication comes here when we're saying it's 15 times whatever tan of 26 degrees is. So if we really wanted to, this might be overkill at this point, but you could put some big brackets around there. So order of operation says take tan of 26 degrees, the brackets, and then multiply that by 15. So I'm going to go ahead and show you how to do that in Scientific Calculator. So it's saying, my calculator, I hope, is somewhat efficient, and it's saying 15 times tan, I've got it off to the left there, of 26 degrees, and I get the answer of 7.3. I'm going to round to 2 decimal places here, so I'm going to say 7.32. Make sure your calculator can get the same thing. Pause this video and make sure your scientific calculator is in degrees and that you get the same answer as me there. So we get this whole answer being 7.32. Notice I didn't take tan of 26 degrees, write out that big long ugly decimal and then multiply it by 15. I just let my calculator carry all the decimals and then round the answer at the very end to 2 decimal places. In the future, we're usually going to ask in the question to round to X number of decimal places. If it doesn't say, we can usually round to the hundredths, so 2 spots after the decimal place, and that will usually suffice for now. Once again, questions on that, email or come to office hours. Next one, very similar. If you want to pause the video, go ahead and try this problem out. Go for that. If you're still kind of figuring things out, pay attention and copy as we go. So first thing I'm going to do is label my theta, label my op, and label my ADJ, my adjacent, because they change every single time depending on what angle we're looking at. So first thing I got to figure out, where's my theta? My theta in this bottom right corner of this triangle. So my theta being 57 degrees. From our theta, we go directly opposite to find our opposite side. So opposite our theta is 14 millimeters in this case, and then our remaining measurement, or the only other side that's not the hypotenuse or the opposite, is y, is that adjacent, or we kind of think of that as the base for now if you like, depending on which way that triangle's faced. So we fill in what we know and what we don't know. Tan theta is equal to op over adjacent. Tan of 57 degrees is equal to 14 over y. Now, a couple different ways of solving this equation when we have the equation or the unknown on the denominator. Some of you will just cross multiply and then divide it to tan 57. That's perfectly fine. I'll take that root first as well. If you want to think of our old method of, well, technically tan 57 is over 1. Everything's divided by 1. So we're just flipping both sides of the equation, same thing we did before, to get that unknown on the numerator. Once that unknown is on the numerator, it's much, much easier to solve. Notice I can just multiply both sides by 14. 14 divided by 14 is 1. Those divide to 1, so you have to multiply this side by 14. So I get 1 times 14 divided by tan 57 is equal to y. We're going to open up our calculator to solve that. Another way to think about solving this equation as well, y is on the denominator, so I'm going to multiply both sides by y. So I'm going to have y times tan 57 is equal to 14. Then I want to isolate for y, so I'm going to divide both sides by tan 57. So if I divide this side by tan 57, whatever that number happens to be, those divide to 1, but if I divide one side by tan 57, I have to divide the other side of the equation by tan 57. And you'll notice we get the exact same thing. Y is equal to 14 divided by the tangent of 57 degrees. So then we just have to type that into our calculator. So these are the same way of solving the exact same problem, exact same way of thinking about it. I find some students like one method, some students like the other method. Take what you want. So that is 14 divided by tan 57. Backspace here. 14 div tan of 57 degrees. Put an end bracket there. You'll see off to the right is 9.09. Question doesn't say, so I'm going to round to 2 decimal places and say that y is equal to 9.09. I think that was millimeters in this case, was it? Millimeters in this case. Oh, sorry, the question does say, now that I read this more carefully, 1/10 of a millimeter. So we actually have to round this to, our final answer should be, therefore, y is equal to 9.1 millimeters, because we are rounding to the 10th column, not the 100th column. Spelled correctly, I hope. So questions on that? Once again, ask away. If you'd like to pause the video here, and could you complete the next A, B, C, D, the next 4 problems here? I will fill those in quick, but hopefully you should be able to complete the next 4 by yourself, and you can just fast forward through to the answers. Okay, first problem here. I'm going to speed things up a little bit. So we're going to say theta, op, and adjacent. Theta is equal to 45 degrees. That's nice. Opposite. That's my theta. I know that opposite is 9. And then my only other remaining side that's not my hypotenuse or opposite is my adjacent, which is x. So always label that opposite before your adjacent. I find it's much easier. So we're saying tan theta is equal to opposite over adjacent. Fill in what you know, what you don't know. Tan of 45 degrees is equal to opposite 9 over adjacent, which is x. So I'm going to multiply both sides by x to get x out of the denominator. X times tan 45 is equal to 9. And then I want to isolate for x, so I'm going to divide both sides by tan 45. So x is equal to 9 divided by tan 45. I'm going to throw this into my calculator. Backspace, backspace, backspace. 9 divided by tan 45 is equal to 9. That's weird. So I'm going to do a little double checking just to make sure everything is good there. What do you notice that tan of 45 is equal to? It's equal to 1. That's a pattern that's going to come up over and over and over. You're going to see exactly why in the near future. So 9 divided by 1 is just 9. So we've got x is equal to 9. And we don't have to round that because that is an exact answer. Okay. Next one, they just put it on an angle to try to trick us a little, but don't be fooled. Theta is 22 degrees. So opposite theta is x. So opposite is equal to x. And then the only other remaining side that's not your hypotenuse, remember hypotenuse is across from 90 degrees, is your adjacent, is 13 mils. So I'm going to speed things up here and say that tan of 22 degrees is equal to my opposite, which is x, over 13. It's nice and easy when your unknown is already on the numerator. So we're going to say 13 times tan of 22 degrees is equal to x. This is just some calculator work here. And we say 13 times tan of 22 degrees, was it? I hope, is 5.25. I'm going to round that to 2 decimals. As we see, the number in the thousandth is a 2, so we leave the number in the hundredth, the 5 is a 5, so that'll stay as 5.25. We'll not round up to 5.26. 5.25. X is equal to 5.25 millimeters, I guess we could say, in our therefore statement. Moving right along here, we have got our theta as 70 degrees. So I'm going to skip some steps here. I know that tan of 7 degrees. I do want to make sure I get this right. Opposite 70 is x, so that must be that is on the numerator. So I'm going to put x on the numerator. And beside 70, or adjacent to 70, is 38. So I'm saying that x, multiply both sides by 38, and 38 times tan of 70 degrees is going to be equal to x. So once again, throw that into your calculator. 38 times tan of 70 degrees is equal to 379.15. 379. Whoa, that seems a little big. I'm going to replace that with 38 instead of just 138. So 38 times tan of 70, that looks a little better, is 104.4. X is equal to 104.40. And that is millimeters in this case. A little box around our final answer. And the last question of this little exercise, we have got 68 degrees as our theta. So tan of 68 degrees is equal to 89 is our opposite, because it's opposite our angle. So we've got 89 over x. One extra step when we have that unknown in the denominator. It's really not that much more work. But you multiply both sides by x. So I'm going to have x times tan 68 equaling to 89. Because x divided by x is 1. Or you could flip both of these upside down, whichever method kind of makes sense in your head. I'm okay with you doing. And then we want to divide tan 68 off of that side to get x all by itself, to isolate x. So we're going to get 89 divided by tan of 68 degrees. And x being equal to 89 tan 68. Let's see if I can remember that. 89 divided by tan of 68 is equal to 35.958. Notice that number after the 5 is an 8, so I'm going to round that 5 up to a 6, so 35.96. And what was that measured in centimeters this case? So I've got x is 35.96 centimeters in this case. I should be writing my units in there. Of course, you're a little more attentive than I, and you did that. Okay. So if you want to double check your answers there, if you just fast forward to this point, you can see we got the answers of 9, 5.25, 104.40, and 35.96. If you're good at solving for sides, you're well on your way. You've done this in the Khan Academy, a couple different exercises. Now we're going to go on to the second part of finding a missing angle. Once again, you've done this in Khan Academy already. We're kind of backtracking in this lesson package, and we're just working with tan to start. Next lesson, we're going to move on to sine and cosine, which you've already taken a look at Khan Academy, solving for missing sides and angles. So first one we have here, if tan 36.9 is equal to 0.75, that's where we're working for the very start, then they're saying tan to the exponent -1. That actually reads tan inverse. That finds the angle if you're given the ratio. So if you know both the side lengths and you want to find the missing angle, we can use this new button on our calculator called the tan inverse. So this inverse, we don't hit to the exponent -1. It's actually a brand new button on our calculator we're going to use. And we use this only, can you put a star beside that? Use this only when looking for a missing angle. So we're going to solve for some missing angles in the next couple problems here. Once again, if you're pretty comfortable with this from Khan Academy, you want to fast forward, play in 2 times speed, or just fast forward to the end and do it by yourself and check your answers, absolutely okay with that. So they're giving us a triangle ABC where angle B is equal to 90 degrees. So I'm going to draw a typical right angle triangle here. For some reason I always put my 90 degrees on the right hand side there. May not look it, but that's perfect, 90 degrees. And they're saying that is angle B, so the capital letter B must go down there. They're saying AB is 15 units long, so from A to B is 15 units long, and from B to C is 20 centimeters long. So question A says to find what is tan of A. Tan of capital A. Well, we know that tan of A is a angle measurement, so I'm going to take a look and I'm going to label this right here. That's the angle we're looking at. So I know that tan uses the opposite and the adjacent. So opposite this angle A, what we're looking at, is 20 degrees. So tan A is equal to op over adjacent. I'm going to rewrite that and say, hey, tan of A is equal to, I know what the opposite is, it's 20. I know what the adjacent is, it's 15. So tan of angle A is going to equal the opposite over the adjacent is equal to 20 div 15. And you notice now we have an unknown angle instead of an unknown side length. To solve for a missing unknown angle, we can't just divide this by tan and divide this by tan, because tan doesn't exist by itself. So tan needs to have an angle attached to it here. So we cannot just divide both sides by tan and then say A is equal to 20 div 15 all divided by tan, because mathematically this doesn't make sense. Tan doesn't exist without a number written beside it. So that would be all wrong. I'm going to erase all that. So what we need to do in order to isolate for A is we'd use this new function called the inverse. So I'm going to take the tan inverse of both sides. So the tan inverse, where we denote inverse is right to the exponent -1. If I take the tan inverse of that side, I need to take the tan inverse of the other side. Take the tan inverse of the other side. So what the tan inverse is the opposite operation of taking the tan of angle A. And that's pretty fancy. If that's not making a lot of sense, know that these two divide to 1. So by taking the tan inverse, then taking the tan, they're opposite operations, so you're essentially doing nothing. It's like adding 2, then subtracting 2. But notice on the right-hand side of this equation, now I'm going to have the tan inverse of 20 divided by 15. And I've got A isolated all by itself on the left-hand side of this equation. So I'm going to switch over to my scientific calculator and take a look at how to get the tan inverse on this calculator, which I have never used before. So I hit function here. Some of you may have to hit second tan, and you'll get this tan -1. So if I hit tan -1, then I go back to my regular, and I do 20 div 15, and I get the answer of roughly 53.13. We're going to round to the nearest hundredth in this case. So play around with your calculator. Make sure you know where your tan inverse function is. I'd imagine most of you will have to hit second function and then the tan button, and you'll see a little tan to the exponent -1 pop up. That is not the same as doing if I did tan to the exponent -1. I don't think it'll even let me do that. Exponent, no, it won't even let me do that. So notice that that is not the same as taking tan to the exponent -1. You have to find that actual tan inverse button. Once again, most of you will be second function tan. So we get the A being equal to 53.13 degrees. So we just found out the angle measurement when we have 2 sides. So we have 2 of the 3 missing puzzle pieces. We have the opposite and adjacent, and we solve for the angle measurement. So the only time we use that inverse function is when we are looking for the angle measurement and you have 2 given sides. So once again, if this is kind of making sense, you've done some practice on Khan Academy, you can pause the video here, try out A, B, C, and D, and then just fast forward, make sure you get the same answers as I do. I'll walk slowly through question A, then I'll try to speed up for question B, C, and D. So taking a look at question A, zoom in not to get confused with that other stuff. They're looking for angle A. So I'm going to label angle A here. Angle A is our unknown angle. Before we called that theta, now they're calling it A. It's the exact same thing. So we say that tan of angle A is equal to the opposite side of that triangle divided by the adjacent side of that triangle. So it's the ratio of our 2 side lengths. So first thing we got to look at is the opposite to angle A is 8. Adjacent is our other side that's not the hypotenuse, will be 10. So tan of A is unknown, we don't know what that is equal to 8 divided by 10. You can always reduce your fractions if you'd like. If you don't see that you can reduce them, it won't make a difference. The tan inverse function will take into account for that, but we can say tan A is equal to 0.8, or 8 divided by 10 is 0.8. I want to isolate for tan, so I want to get A all by itself, so I'm going to inverse both sides. So here I'm going to take the tan inverse of both sides to get rid of that tan. But if I take the tan inverse of one side, I need to take the tan inverse of the other side. So I'm going to be left with A is equal to the tan inverse of 8 over 10, or you can reduce the fraction if it's nice and easy, of 0.8. Oh, sorry, tan inverse. Forgot that inverse there. That's very important. So flip to your scientific calculator and do second function in tan, and you get that tan inverse. And take the tan inverse of 0.8, and we get the answer of 38.65. If I'm rounding to the nearest hundredth, you see there's a 9 after that 5, so I'm going to have to round that 5 up to a 6, so I'm going to take 38.66. I'm just going to double check and see if our question asks us to round to 1 decimal place. It does ask us to round to 1 decimal place. So that 6 is going to round up to a 7. So I'm going to have the answer of tan inverse of 0.8 is 38.65. 7 degrees. Making sense? Moving on. So angle F. So first thing I'm going to do is label that angle. This is the one we're looking at. So opposite that angle is our 20 mils. So tan of F degrees, don't know what F is, going to leave it as F, is the opposite, 20 mils divided by 20 mils. Can you guess what this is going to be? So if we take 20 divided by 20, we get the answer of 1. You can reduce that ratio as much as you'd like. And if you're unsure what this is going to be, you don't remember from the previous question, we know we take the inverse of both sides to isolate F all by itself. So I'm going to start skipping some steps and just say angle F, you could put an angle sign there if you wanted, is the inverse of 1. So what is tan inverse of 1? 1 is equal to 45 exactly. Remember getting that answer before? So F is equal to 45 degrees. Angle F, we should be putting a little angle sign there, is equal to 45 degrees. Nice and quick. Moving on. C. Find P. We should have angle P here, technically speaking. So first thing I'm going to do is label my angle. So P is up there on the top right. So opposite, I'm getting kind of bored of this hot pink. I think I can switch over to blue. P is that angle on the top right. So opposite P is 14 centimeters. So tan of angle P is equal to opposite. Opposite is 14 divided by adjacent. Adjacent is the only other side that's not the hypotenuse. And then to isolate for P, to get P all by itself, we take the tan inverse of both sides. I don't know how to reduce 14 over 11 very easily, so I'm just going to leave it as 14 over 11, and I can type that right into my calculator. Don't write it a long decimal there and try to type that into your calculator. Let your calculator carry all the decimals for you. So tan inverse of 14 divided by 11 do an end bracket there, and we get the answer of 51.84. So we're rounding this to one decimal place, so 51.8. P, angle P is equal to 51.8 degrees. Make sure you get the same thing on your calculator there. And last but not least, find angle K. So angle K, there's what we're looking for. I'm going to label angle K first and take a look at what is opposite angle K. So tan of K is equal to 56 over 38. We get pretty quick at these, so we can say angle K is equal to the tan inverse to isolate for, there's a bad inverse sign, tan inverse of 56 over 38. So angle K is equal to 56 div 38. See what that is. 56 div 38. And we get 55.8. Hopefully you got the same thing there. 55.8 degrees. So if you fast forwarded along, you can see our four answers are angle A is 38.7, angle F is 45 degrees, angle P is 51.8, and angle K, with a box around it, is equal to 55.8. So that is how we solve for a missing side and a missing angle using the tan ratio only. In Khan Academy, you've already gone over this sine and the cosine ratio. We're going to go over that next class.